So in this video, I'll discuss how you can produce or calculate the concentration of solutions in a variety of ways. So keep in mind that concentration simply gives us a ratio of how much solute is present inside of a solution. Recall the solute is the substance that is being dissolved. It's present in a smaller amount. The solution is combining the solute and the solvent. The solvent is what is that solute dissolved in. Once the solute and solvent combine, they form a solution. So the key with concentrations is that you have to think about how much of the substance was dissolved and what is the total amount of solution that is present. And so one key thing to keep in mind is that sometimes your solution amount will be provided. Other times you'll have to generate that by combining your solute and your solvent. So that is one thing that you do want to keep in mind. Some other things when thinking about concentration, there are different ways that we can report it, but regardless of how it's reported, it's giving you the amount of solute of what was dissolved is present. One of the more common ways of reporting concentration is molarity. So molarity, which we indicate with a capital M, molarity tells us the number of moles of solute divided by a liter of solution. And so that M, capital M for molarity, also means moles per liter. And so the way that you calculate that value is by converting your solute to moles and converting your volume of solution to liters. So not the volume of solvent, but the volume of solution. Some other common units, you have your mass percent, and you'll sometimes see that written as a percent, M/M. And with this one, it just means mass of solute divided by mass of solution times 100%. And so that name kind of indicates how you're going to actually calculate it. Recall a unit of mass is the gram. So if you're dealing with the mass of your solute and your solution, both are in grams, and you're getting the ratio of the amount of solute to solvent, amount of solute to solution times 100%. We can do the same thing with the volume percent concentration. You'll see that as a V/V. With this one, you have milliliters of solution and milliliters of solute. So solute divided by solution times 100%. We can do mass volume percent. It's like you're combining those two. With the mass volume percent, you have the mass of solute, you have the milliliters of solution times 100%. So these are some common ways that you can see your concentrations reported. You also have others that are used for very dilute solutions such as ppm and ppb. ppm and ppb, they are very similar to the mass volume percent. So for instance, ppm is still mass of solute, milliliter of solution, but the difference is if you're doing a mass volume percent, you're multiplying it by 100%, so that ratio of solute to solution. ppm means parts per million. Once you have that ratio of solute to solution, you multiply it by 1 million. ppb, which is parts per billion, you start out the same way. Mass of solute, milliliters of solution, but you're multiplying that by 1 billion. So the key with reporting concentrations in a variety of ways is simply understanding what does that concentration represent, and that gives you a clue as to how it is calculated. So we'll do a couple of examples. First example as to calculate the molarity of a 654 milliliter solution that contains 0.84 moles of calcium chloride. So when you go through the problem, go back and look at what information is given and what are you looking for. So the problem says to calculate the molarity. And so we can stop there. We know that molarity is equal to moles of solute over liters of solution. It then gives us that we have 654 milliliters of solution. The fact that this is actually the solution and not the solvent is important because we now have the solution amount that is present. However, it gave it to us as a milliliter. And so recall molarity is moles per liter. So that means that we have to convert this to liters. We're given milliliters, so in order to cancel it, I need milliliters on the bottom. I'm trying to go from that to liters. And so recall the relationship. Milli is 1,000 times smaller, so it takes 1,000 milliliters to represent 1 liter. So that means that this volume is equivalent to 0.654 liters. And it also gave me my amount of solute, which was 0.84 moles. So I don't have to do any conversions with that because it's already in the units that I need. So that means from there I can simply plug into my equation. Molarity, I have my moles, 0.84 moles. That's what the problem gave me. We just converted the volume to liters, so that's the value that we would use in this equation, 0.654 liters. From there, you put that in your calculator, 0.84 divided by 0.654, and when you put that in your calculator, you get roughly 1.3 molar. So you can show it as 1.3 with a capital M, or you can show it as 1.3 moles per liter. They represent the same thing. And so that is one example. We can do another one. Still asking us to calculate the molarity, but if you notice now, it says that we have a 40 milliliter solution that contains 0.2074 grams of sodium hydroxide. So now we're still given the volume in milliliters, which is what we had previously, but now we're given no longer the moles of solute, but instead the mass of solute. Still asked to calculate molarity, so we still need to use this equation, moles per liter. We have our volume. So again, because it was in milliliters, we have to convert that as we just did. Get rid of the milliliters so that we're left with liters. It takes 1,000 of those smaller units to make one larger unit. So that means that my volume is 0.0400 liters. But it gave me the mass of sodium hydroxide. I need moles of sodium hydroxide. So I have to put that in my calculator. And so we have to do that conversion. 0.2074 grams of sodium hydroxide. So then you have to ask yourself, can I go straight from the gram to the mole? And of course, we can, because the molar mass allows us to identify the relationship between the mass and the mole of an object. So recall, if you look at your periodic table and you add the average atomic mass of each of those atoms, you have that one sodium, which is roughly 22.99. You have that oxygen, which is roughly 16. The hydrogen, which is roughly 1.01. When you add those together, you get 40 grams for every 1 mole. So your 0.2074, when you convert that mass to moles, so divide that by 40, you end up with 0.00519 moles of sodium hydroxide. From there, we now have moles of solute. We now have liters of solution, so we can plug it into our equation. So we have 0.00519 moles. We have 0.0400 liters. So when we put that in the calculator, so 0.00519 divided by 0.04, you end up with 0.130 molar. Or again, we can write it as 0.130 moles per liter. And so that's two ways that we can calculate molarity. We could have also done that same last solution, the 40 milliliters with the 0.2074 grams. We could have done that same calculation by determining the mass volume percent. Again, depending on what percent, what unit, or which version you're using, that dictates which equation you use. So if we're doing the mass volume percent, we're going to use the mass of solute, which is going to be in grams of solute, the volume of solution, which is going to be milliliters of solution, times 100%. And so the problem already gave us everything that we need. So for this one, we simply plug it into the equation. So our equation, we have mass volume percent. The problem gave us 0.2074 grams of solute. And it told us that we had 40 milliliters of solution. So the key is being able to identify which concentration you're asked to calculate, because that will determine what your units need to be. Molarity, we had to convert to moles and we had to convert to liters. Mass volume percent, we need mass, so grams for our mass, we need milliliters for our volume. So when you put that in your calculator, you have 0.274 divided by 40. You have to multiply that by 100 for your 100%. And that gives you a mass volume percent of 0.519%. So before, when we calculated the molarity, it was 0.130 molar. Now our mass volume percent is 0.519%. That's a very small percent. We could have done the same thing with ppm, parts per million. Again, with the parts per million, it would start out the same way. We still need grams of solute, milliliters of solution, but now we're multiplying by 1 million. And so when we do that, we still have our 0.2074 grams. We still have our 40.0 milliliters, but now you're multiplying by 10 to the 6. Now, when I put 10 to the 6 on here, that's really the same as me saying 1 times 10 to the 6. So just keep that in mind when you're calculating it. You're going to be multiplying by 1 times 10 to the 6. I just didn't write out that 1. When you put that in your calculator, you're going to end up with 5,190 ppm. And so this is how you go through and calculate concentration in a number of different ways. The key is just knowing the equation for that concentration. And most of them are based on, they give you clues in the name. The name is kind of dictating how and what units you need to use in order to calculate that concentration value. And so that's what you want to consider when you're being asked to calculate different concentrations. So I hope that this helps. If you have any questions, please let me know. Thank you.